All right, so we left off on page 422, how to use SQL to work with the data in a relational database. Hopefully, what we'll talk about right now, it'll come back to you as far as what we did last semester, because syntactically, it's not going to be very different between the way we did things in MySQL last semester and the way we will do things in SQL Server this semester. All right. It says in this section you'll learn about the 4 SQL statements: select, insert, update, and delete. Hopefully you remember this. I'll just put it up there so you see it again. Adding to this list that I've been putting up here, there are what are called data definition language statements, and there are data, make this wider, manipulation language, or DML statements. All right. If you look up on the screen here, the data definition language statements, I'm just going to put them all in caps. They're called create, alter, and drop. All right. So there's 3 types of data definition language statements: create, alter, and drop. And they work with the structure, also known as the schema of the database. So they're kind of, for lack of better words, working behind the scenes. All right. I guess if you needed an analogy, maybe not a great one, but when we talk about HTML documents, we've got the head section, we've got the body section, and the head is the kind of stuff where you put all your stuff for the system. That's kind of what DDL is. So we will talk about create. So you can create a table, you can create, a view, etc. You can alter a table, you can alter a view, or you can drop or get rid of one of those. All right. On the other hand, with a DML, those are select, update, insert, and delete. And again, hopefully you remember those from last semester. It is not at all inconceivable that if you go in for a programming job, a job that has programming related to it in any way, they will expect you to have at least a fundamental understanding of database and database terminology. All right. Now, remember, if you look up on the screen here, this one's special, the select statement. In many ways, it's special, and it's special because the select is the only one that doesn't change the data. All right. So, for instance, if I wanted a listing of everybody in this room right now, let's say I wanted an alphabetized listing based on last name, okay? I could do that. But if I decide I wanted alphabetized based on last name, but in reverse alphabetic order, I'd be getting kind of the list flipped up, turned around on its head, whatever you want to say. So with a select statement, that allows you to view part or all of your data in any format you want, but you cannot change the data. All right, that has to make sense to you. On the other hand, when you do an update, or you do an insert, or you do a delete, if they are successful, they must change the database, because you're either changing existing data, adding new data, or removing existing data. All right? So the select does not change data. The update, insert, delete, if successful, must change data. All right? Unless you try to update or insert update or delete something that's not there, but you're going to get an error if you try to do that. All right. These things when you create something, that's how you, if you need a new table, that's how you create it. So if I've got if I need to create a table for each one, that's going to hold all of you, I create a table. All right, so I create the table, and I decide, oh, you know what? I didn't put in middle initial. I left that field out. Then I would be altering. I would alter the table. Does that make sense? Thank you. Everybody got a chance to copy those starter exercises? Good. All right. And if I decided I didn't need the table anymore, I would drop it. All right. So the first thing that they discuss in the chapter here is how to query just a single table. Of course, as you'd guess, that's the easiest. And hopefully this statement, if you look right here in the blue, that statement hopefully makes sense to you. It's saying what? Go over to the products table and grab me every product ID, every name, and every unit price, as long as the category ID is props. Then take the answer and give it to me in ascending order based on the unit price. And again, hopefully you remember this from last semester, that query that you see up there in the blue, after order by unit price, if we put DESC in there, it would give it to us in descending order instead of the default ascending order. So any field you can put it in ascending order, which is what you get by default, or you can put ASC if you want to. But if you want it in descending order, you must put DESC. All right. So again, what the author says here, what we're talking about now is SQL, Structured Query Language, and how SQL is basically handled in this relational database management system. Now, the thing is, if you look up on the screen here, that query right here, that's exactly the same as the way you write it in MySQL. There's no difference. And just like MySQL, again, please look at your book or at the screen. This is case insensitive. The author has chosen to put all keywords in uppercase, but you don't have to. All of it could have been in uppercase, all of it could have been in lowercase, or as you see, we could use mixed case. Any of those would work. This is not case sensitive. When you run a query, what you get back is known as the result table or the result set. Unless you save that result table or result set, it's gone. So I run a query on all of you. I say, for some goofy reason, I want to know everybody who has an I in their first name. Okay? So I select, names. I select first name from students where, let's say first name, like, it's got an I in it. I'd have to write a like statement, but I do that. All right, now I want just the ones with G's in there. So I go back and I write it again. Now that original information that I put in there is gone. Because result sets, by their very nature, are temporary. What we'll talk about in just a minute is you can use what's called a view. All right, and if you use a view, you can save your result set. Now, the other thing to realize too is this right here, this select statement, that is a query. All right. You can write select queries, you can write insert queries, you can write update queries, you can write delete queries. They are all queries. What we have to learn, and we really have not done thus far, is we are going to be able to write queries inside of C#. Actually in C#. But you're going to have, and it's going to look very similar to this, but you'll typically create that as a string. You'll create that whole query as a string. Then you'll run an execute command on it. Then you'll do whatever you want to do with it. And if I'm making it sound hard, it's not that as hard as it probably sounds. All right, it's just that I can't type this in directly into C# or into ASP.NET because it doesn't understand databases by default. I've got to make it a string, operate on the string, and then do what I want to do. Okay? Remember, if you want to select everything, you use the asterisk. Okay? So if I say select star from products, I get everything in the products table. One thing, because people will always say, well, if I do select star from products, I'm going to get everything in the products table, and I'm going to get it in order based on the primary key. That's normally how you get it, but there's no guarantee of any order when you use select star. Did everybody hear that? Because that's really, really important. Because if I'm querying a database that's got 1 million records in it and I do a select star, I may not get the stuff back in the order I think I'm going to get it back in. So I can still say select star from products, then I can say order by product number or something like that if I want to, or order by price or whatever. The other thing is, just so you know, saying select star, especially if you've got a table with quite a few fields in it, it's a resource hog. So if I'm doing a select star and I've got 12 fields that are in a table, but I only need 3 of them, if I do a select star, then I'm grabbing 9 fields that I don't need. And if there's 1 million records, that's 9 million basically types of partial requests that I don't need. You should only use select star sparingly, ideally only on very small tables with just a field or 2 in them. All right? But in an ideal world, you'd never use the select star. Besides that, if you do a select star, it's got to the field names have to be in the order in which you define them. So in other words, if I've got in my table first name, middle initial, last name, but I decide when I want to do a query, I want last name, then a comma, then first name, then middle initial, I can't do a select star. I can't because I don't get it in that order. I'd have to actually do a select and list the field names out individually. All right. Hopefully that's enough on a single table that at least jogs your memory somewhat of stuff that we've talked about previously. All right. How to join related data from 2 or more tables? There is no limit. Okay? So in other words, going back here, what are we on, 424? If I do, for some reason, have to write the query from hell, and you wrote a few of those, if you remember, in some of the worksheets that you did, if I need information from every one of these tables, then I have to join all 6 of them together. That's not really a very big database either, just so you know. But quite often, the information that you want will not be in just a single table. You will have to join together multiple tables. There are 2 basic ways of doing these joins. We went over this last semester. You can do this. You can say inner join on, which is totally fine to do. All right? The way that I was taught to do it will also work so if I've got this, something like this. So I've got categories, products, and line items. All right, that query. So let's just say I was going to say select star. That'd be stupid, but let's just say that anyway. All right, I could also write it then as select star from categories, and I probably would give it a C there. I'll probably do some aliasing. We talked about that before. Products, line items, and I can say where C dot category ID equals P dot category ID and P dot product ID equals LI dot product ID. And please take a look at that. Hopefully that'll jog your memory a little bit. I will tell you, this is considered the new school way of doing it, and this is considered the old school way. The claim is that this will run faster than this does. for what we're doing, unless you're talking about records in orders of magnitude, like in the millions and whatever, there's no difference. I mean, do you really care when you hook this up to the system clock that this takes 0.06 of a second and this takes 0.03 of a second? Probably not. Okay. I don't really care which one you use. I use them both, but I tend to use the second one. And again, you got to remember, when I went back, when I was doing this stuff, it was in the late 80s. It hasn't changed. I did the same kind of stuff that you're looking at here. I had to design databases. I had to write queries for databases, but we didn't even have this way of doing it then. We all did it like this. All right. So like I said, you'll see both too out in the field. It just depends on what a person is comfortable with. And fortunately or unfortunately, sometimes you'll see them both. If you've got code that's written by two different people and one does it one way and one does it the other way, and it's put together into the same file, all right, you could have to do it both ways. So they show you an example here. They show you the syntax at the top of the page. There's their example. You should know that. Why do you join tables together? Because you join tables together if and or when the information that you need is in more than one table. All right. Again, none of that should be a surprise to you. So in this case, again, you'll notice, what do we want? We want the short name, we want the product ID, we want the name, and we want the unit price. All right? And that information exists in 3 different tables. So again, we could do this, but you see that select statement that's right here. So if we were going to do that, going back to here, you'd have to figure out how to do it. All right. There are some graphical tools that exist that will do some of this stuff for you, allow you to literally go in there and pull things out, but they cost money. All right. Do you all know about this? I just want to mention this to you, that Colin today asked a question in class, in the morning class. And he said, I don't mind Notepad++. I don't mind brackets. They're both okay. I've seen other packages. Why doesn't Visual Studio have their own thing where you can just use Visual Studio? And you may or may not know it. You may or may not care what I'm about to tell you. I don't know. But, grab that one. Visual Studio has come up with something that's called Visual Studio Code. It's fairly new. It's not brand new, but it's fairly new. And it's a stripped down version of Visual Studio that, again, is free, but it's designed to work with all sorts of different types of packages. All right? It's funny because he went to download it, and it asked him about like changing his registry and some other stuff. And he's like, should I be doing this? And I'm like, I'm not going to tell you yes or no, because I don't want to tell you to download something that screws up your machine. So I said, it's an individual decision. It wasn't a registry, but it was something else. All right? It wanted the ability. And I said, why don't you Google what it's telling you to do? And he did, and it gave him somewhat of an explanation. All right? So again, as mentioned, a join lets you combine data from 2 or more tables and get a single result set from them. Probably 90 to 99% of the joins that you do will be what are called equijoins. An equality join like the one we just looked at. They don't have to be, though. You can use greater than, less than, greater than or equal to, less than or equal to, and not equal to in joins. Typically, that's not what you're going to do. You can also do left joins where you grab everything on the left, all right, and everything on the right, but no, I'm sorry. You can do a left join where if it's a left, inner join, you grab everything on the left regardless of whether or not it has a match on the right, or you can do a right inner join where it's the opposite. All right, you can do inner joins, you can do outer joins, you can do equijoins, you can do non-equijoins. All right. But you'll notice when you do joins like that, all the joins we've looked at thus far, and I think virtually every join you do is a select statement. So you're not changing the data. And that's done partially to protect you. You shouldn't be able to be in one query using a select statement, or really using a join. You shouldn't be able to be changing a ton of data in other tables. You shouldn't be able to do that. But if you do want to add or delete or update data, here's the way we do it. Again, you may or may not remember that. This is virtually identical to what we did last semester. Okay? The reason that I used MySQL was twofold. It's free, and the syntax is very, very, very similar to the syntax that you have for SQL Server. All right? So there's an example of an insert. Insert into categories. If you're going to insert and put every field in, you don't need to list the field names like that, but it's always considered a good practice to do that. And then values, and you put it in. Okay? There's an update. When you update, if you don't put a where in, if you remember this from last semester, if I left that where out that's right there in blue, and I said update category, set short name to Hawaiian cuisine, or Halloween cuisine, then everything would be Halloween cuisine. Not just the category of food, but every category. So you have to remember when you're doing deletes and when you're doing updates to always have a where statement in there, unless you want to change everything. Again, the classic example of that is you go into a payroll database and you want to give people in one department a 10% raise. If you say select star from employees where department equal this and give them that, all right, or update where that's the case, then you'll just change those. But if you forget the where, now everybody got a 10% raise. And if it's me, I'm not telling you. Okay. Finally, the delete. That deletes, in that case, every record from that categories table that has a category ID of food. Again, if you leave the where off, that deletes every record from the categories table. One thing to realize, I do want to mention this isn't in your book, but if you look right here, let's pretend for a second, I'm going to just cross that out. So let's say we typed in delete from categories. Everybody with me? So we did that. That removes every record from the table. That makes sense? But the table is still there. So if you decide you want to fill it up again, it still has the structure to it. Okay? If I want to remove it, physically remove that table, then I'd say drop table categories. That will not only remove every record, that will remove the schema or the structure from the table as well. It's gone. And there is no way that I know of. If you do that, don't think, oh, I didn't mean to do that. I'm going to Control Z. That doesn't matter. That doesn't do anything. If you remove something, it's gone. So a lot of times what people do is instead of removing a table, they'll go and they'll create another database and they'll make like a log, so they've got a copy of what it all looked like. All right? So you use insert, update, and delete to maintain the data in the table. All right, the insert can be used to add one or more rows to a table. You can list multiple rows in here if you want to. All right. The update and delete can be used for updating or deleting one or more rows. There's the warning about the where clause, which I've already told you about. All right. How to work with other database objects. Now, the example they give in here is actually not a good example, in my opinion. You see this right here? Let's assume I run this query every day, the one that you see up on the screen in blue. So every day I'm running select star from customer main where state equal California order by, so we do this, all right? If I come through here, and at the beginning of this query, I type in create, view, let's just say I call it X. It's a dumb name, but let's just say I call it X. And I put a semicolon right there, all right? Now, every time I say select star from X, it runs that query. All right, so a view that they're talking about, a view is a saved query. All right. You have saved what you're doing with the query, and now you can bring it up and run it. Now, if this had a lot more lines, if this had 10 or 15 lines in it, it's really going to buy you a lot doing it that way. I think I told you this, but I'll always remember John Sissons, one of my old students from Blackhawk, that he told me that he wrote a query once that was 13 pages long. He was drilling through a database in the Department of Natural Resources for the state of Wisconsin, where he was going through several million records looking for 1 or 2 or 3 records that met the criteria.
Views can be added like items, can't they?
Like what?
Like items in Visual Studio.
Are you saying can you add them like you would other components of a database?
Yeah.
Yes.
Just like how you would add a page or something, go through
No, not like that. No. So this is what they showed you. Create, view, So in their example they're showing here, if you say select star from customers min, it runs that query. Okay? So they give it to you in more depth here. A view consists of a select statement that's stored within the database. Because views are stored as part of the database, they're managed independently of the applications that use them. Okay? Now it says views can be used to restrict data. That's where the word came from. Remember I gave you this example last year? I said if you walk into a bank and you walk up to a teller and you say, can you tell me some information about my car loan? They're not going to be able to, by and large. Would you agree with that? Tellers are designed to give you money, take your money, and tell you your balance. But their only other function is to say, you've got to see a personal banker for that. And I don't mean to say that to demean them at all. I'm not. I'm just saying they have a set job. All right? Their view of the data, I don't believe that a teller could probably go in and even look up your loan. All right? They'd have to defer to a personal banker because they have a different view of your data. All right? One group of people has a different view of data than the other group does. All right. What we will get into this semester that we did not do this last semester, and that is talking about stored procedures. Stored procedures is where code comes in. And if you'd please look up on the screen here, because this is the most important part of this, this language uses the @ sign right there. If you look on page 431, that's what's called a runtime parameter, sometimes just a parameter. That means that every time I run that query, I can put in a different state in this case. So I could run it 50 different times and get that information from each state. But you'll notice that in 2 places there, up here and down in here, they show you that. In some languages, instead of using an @ sign like they use here, they use a question mark. But when you write a stored procedure, you are writing something like this and saving it. The stored means that it's saved. Then you can bring it up and run it on an as-needed basis. We will be doing some of that as well as we go on in here.
You talking about like PHP? It's a question mark.
PHP is, there are several languages that do that. PHP does some stuff with question marks, yeah. So as it says on the bottom of the page here, a stored procedure consists of 1 or more SQL statements that have already been compiled. It's like a mini program, and it's stored with the database. They can improve database performance because they've already, for lack of better words, it's like anything else. It's kind of like, okay, I want to get better at guitar. How do I get better at the guitar? What's the one word? Practice. So you could look at it that what you're doing every time you're running this stored procedure, you're practicing. The system knows what to do. It's already compiled it. If there's any optimization that it can do internally, it's done it already. Notice it says these stored procedures can also contain control of flow languages. What does that mean? That means that they can have loops, they can have if statements, they can have switch statements. All the stuff that you've learned about already. All right, the last part of the chapter, the last, 2, 4, 6 pages, starting on 432, they're the hardest part of the chapter. All right, and this is the kind of thing where it's going to make more sense for you to constantly be going back to this. All right, and I'm going to just go right to, I'll talk about it, but I'm going to go to the pictures that are shown here. This is the picture on page 433 in the book. All right, and notice they have basic objects here. And it says Figure 1210 presents the primary ADO.NET objects that are used to develop database applications. To start, the data that's retrieved from the database is stored in what's called a data set. And that's the first picture that you see there. All right, that contains one or more data tables. So this data set, for example, has only one data table in it. But if I was doing a join, it would have to give me 2 or more tables. Okay? To manage the flow of data between the data and the database, ADO.NET uses what's called a data adapter. So the data adapter, for lack of better words, is kind of like a go-between. Its job is to funnel information to and from the data set. To do that, as you can see, it sends information to the command object and gets information back. The command object sends information to the connection object and gets information back. The connection object goes to the database itself and gets information back. So you'll notice that with every relationship, every one that's in this picture, the arrows go in both directions. All right? So it can provide information, and it can retrieve information, is what they're saying. When you use an SQL data source to work with the data in a database, the data is stored by default in one of these data sets. All right? There are ADO.NET classes that manage this stuff for you. What you'll see when we look at the first example in Chapter 13, the next chapter, what you'll see in there is you'll be able to write the first application without writing a line of code. You will have to write some ASPX stuff, but you won't have to write any code yourselves. That typically works, but only in a very simplistic type of situation. In other words, that will not work when you have to customize things. When you have to customize, you're going to have to write some code. So we'll very quickly get into code mode, for lack of better words. When you use an SQL data source, the connection to the database is automatically closed after each operation. Did you hear that? That's a very important statement. When you use an SQL data source, the connection to the database is automatically closed after each operation. The reason for that, I've given you this example. Think of a ticket place. Think of Ticketmaster. They can only hold open their window of tickets for like 90 seconds, and you pick one or you lose it. All right? And it's the same thing here. Because of that, the application works with a copy of the data that's stored in the data set. So in other words, it's not connected to the real database anymore. In fact, it's known as a disconnected data architecture, what you see in the picture here. You can still update it, but you're working with a copy. That can lead to issues, and we'll talk about those in just a minute. This disconnected architecture, though, it improves system performance because it uses less resources. So they show you this, and then they explain it for the rest of the page. I don't want to read to you. You can see the stuff that's there. All right? You don't have to memorize it. You just have to realize that there's a lot of stuff that goes on behind the scenes. Like it or not, that's the way that it is. All right, where this leads to problems. Just this isn't the way it works, but let's pretend for a second. All right? There's going to be a concert. And although I'm sure we probably don't share all of the same musical tastes, Amin and I decide we both want to go to this concert. Okay, and they just started selling tickets. And we both go to Ticketmaster. And I get there first, but it doesn't matter. It says I've got the next 90 seconds, and I can pick any seat I want. And I look, wow, look, there's 2 seats in the front row. There's just 2 left. I want those. Now Amin gets in, and for some reason, it didn't lock him out while I was in there. So I said, I want my 2 tickets. I get out. Now Amin's still in there. Oh, wow, there's 2 tickets, and they're the 2 I want. Okay? He chooses them also. Who gets the tickets? Depending on how it's set up, it very well could be Amin. I might even get charged for them. All right? But he gets them because it's last in wins. Okay? That's what's called concurrency, when you've got 2 different people or 2 different groups that are trying to access the same information at the same time. All right? And that's when it can be an issue. All right? Because if I'm making, if I'm changing Amin's record, and now let's just say Mr. Corrigan comes in after I do, and he changes Amin's record, and we don't have good concurrency set up, he overwrites every change I've made, and my changes are not there. So this is what they talk about on pages 434 and 435. In fact, if you look, it says here, let's just look at the text. What happens when 2 users try to update the same row? When they say the same row, do you all understand? The same record. Okay? So if it's all of you, let's suppose I'm trying to update your records. Let's say it's December and it's grade time. All right, now somebody from St. Louis tries to update the same record. Let's say Amin moved. So they want to update his record. Well, he got an A in this class. Of course he did. So I want to put A in there for his grade. And I do that, but they're opening up the record at the same time. All right? And they go in there, and they change his address. But I've saved already. Now they save right over mine. Since we're both working with a copy, they did the last update. So you don't have a grade. Okay? So now I get a nasty call from the same people who screwed it up and say, how come everybody in your class has got a grade except Amin? All right? So it says there, when 2 or more users retrieve the data in the same row, it's called concurrency. Because we're using a disconnected architecture, you can't stop that from happening. Because if we were all using the same copy of the Halloween database, we could all open it, because that's how it works here. All right? So how do you combat that? It says, if 2 users try to update the same row at the same time, and I'm not talking about the same second, but we both have it open, we have the same table open, and we both update the same record or records in the table. All right? So it says, if 2 users try to update the same row in a database at the same time, the second user's changes, so the last one could overwrite the ones made by the first user. Whether or not this happens depends on how concurrency is set up. And there's 2 basic ways. All right? The first is called optimistic concurrency, as you see right there. It says the program checks to see if that row is going to be updated or changed. Has it been changed? Has somebody changed it and written it back since I've brought out my copy and wanted to make changes to it? Does that make sense? And if that happens, the record gets locked. You're not able to do anything. In other words, two people can't change it at the same time. You can't do that. What happens instead is it throws what's called a concurrency exception. All right? And then typically the second person is going to be frozen out, and your program has to handle that. All right? Sometimes that's considered very drastic. So if you don't have optimistic concurrency, then you get the worst one that we just mentioned. And that literally was referred to as last in wins. Okay? So you typically want to have some kind of concurrency. Now, if we were to talk to Ms. Zika and she said, oh no, once you change this, there's absolutely no chance that two people will want to be writing to the same record at the same time. All right? In the back of my mind, I'm thinking BS, because that isn't going to happen. When she talked about all those different people she has working there, and how a lot of them like to change or need to change the same records, we would not want a last in wins concurrency type of thing for them. You wouldn't want it. Even if they said it'll never happen. Well, it'll never happen until it does. And then they're going to call you up and ask you why it doesn't work. And for you to turn back and say, well, you told us it never happened, that's not going to cut it. Right? So how do you avoid this? This is the bottom of the page here. It says, for many applications, concurrency errors rarely occur. I mean, there are a lot of databases that once they're set up, either they don't change much or they're only changed by one person. And you know it's either one person, or you can be guaranteed it's only going to be one person at a time. Maybe you've got 3 shifts of workers. All right? Valerie works from 6 to 2. Tiffany works from 2 to 10. All right? Etc. That kind of thing. They're the only ones who could change it. So that would be okay. All right? If concurrency is likely to be a problem, a program that uses the data set can be designed so it updates the database and refreshes it frequently. All right? That way, you're less likely to have concurrency errors. The other way to do it, again, you're trying to. Notice it's saying, this really should be said, how to try to avoid concurrency errors. The last one is you use a system where you only get a record at a time. So if I want to change Ethan's record, that's all I get. And then I can set it up so if I'm trying to change records and so is Evan, and Evan brings up Ethan's record or tries to, it says, no, that record's currently being used. So he's locked out of it. But he can use anybody else's records or view anybody else's records and conceivably change them. So if he comes in and says, okay, I'm going to change Amin's record then. Now I get done with Ethan's, I write it back. Now I try to bring up Amin's, I get the same error. All right, or warning, or however it's set up. So that's what's shown pictorially here on the top of 435. But I tried to explain it to you. Hopefully what I said made sense. All right, the last thing that you can do is you can also work with data without using a data adapter. So this last one is how to use data without a data adapter. All right? And in order to do that, typically what you end up using is what's called a data reader. If you look on here, if you look up on this picture that we looked at before, that one, there's nothing that says data reader. All right? The key thing about a data reader, and this is on page 437, and this is all stuff that you should understand because we've talked about it in other kinds of languages. If something is a data reader, it's read-only. Does that make sense? Not only that, it's forward direction only. If there's 15 records and I've already read the first 6, now I want to go back and read record 3, I can't do it. It only goes forward. So if I've read the first 6, now I can read 7 through 15. I can't go back and read the earlier ones. It's also sometimes called a fire hose because when the fireman turns on the water, it goes out. It's not like you can push the water back into you. All right, it's the same type of principle. All right, so they mention here, instead of using the data adapter, You can execute the commands directly. All right. You use a data reader. It says to insert, update, or delete data in a database, you execute a command that contains an insert, update, or delete statement. All right. You're not going to use those with a data reader because it's read-only. But if you're doing a select, especially, it would make sense to use a data reader. And while you're working on an application, you can use a combination of data readers and data sets.
So
All right.
what's wrong with it not going backwards?
It's not necessarily. But what I'm saying is, let's assume that I'm using a data reader and I'm using a while loop with it, and it's showing me a record at a time. Okay? And let's say I'm even pausing after each record for 5 seconds. So I've read the first 6 records, boom. Wait a minute, there was something in record 3. Didn't we already have that? I can't go back and look at it again.
Run another one, I guess.
Well, you could run it again, or you could decide if that's going to be an issue, not to use a data reader, to use a data set. That's what the authors say. But you might say, geez, I should just use data sets all the time. But data readers are much faster. Okay?
Would it be fast enough to like run
Pardon?
one to another one or something like that? And then just run to
You could do something like that, yeah. So that's,
I mean, is it that fast, like, comparatively?
well, again, is it going to matter in here with the size databases we're working on? Of course not. But for Amazon, it very well might. All right. If I'm preparing information and if I can just quickly kind of look at it and know, boom, 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 yeah, that's what I want. I'm going to use a data reader if I'm preparing a report for somebody. All right. And a lot of what this stuff is done is going to be for reports. Because let's face it, managers aren't happy unless they see reports. All right. If they don't have one, they make one up. No, I've worked for enough people. That's the way it is. All right. They need to justify. Oh, we need more money for this. Write a report. Give me these fields. Then sometimes you give it to them. Oh, that didn't justify it. No, right. Give me a new report with some different stuff in it. All right. Because you're all fighting for the same money, etc. Typically.
Wouldn't it be more the person, like on the person that's doing the analytics stuff?
It depends. It's the old joke.
They like yell at more?
If you look at this, sales don't look good, right? Oh no, but if you stretch it out, we still got a long ways to go. I mean, I've been in meetings where that's happened. People have rewritten PowerPoints and whatever to make stuff not look so bad. And I'm thinking, okay, I don't know if the people that you're doing this for, the people who are at a higher pay grade than I'm, are that stupid or not. But we all know what's happening. All right.
And just like scale it closer together or
Yeah.
something like that.
Now again, you'll notice in here, there's no end of chapter exercises. This is one of the few in here. There's nothing. I think before we go on and start taking a look at chapter 13, let's take another break. All right, it's 2:33. Let's come back and let's make it about around 2:45.